I trust everyone watching this video is having a great day or a great evening, morning, night, depending on where you are in the world. I am Mr. Rich. Thank you for joining me for this video. Sine, cosine x, dx, lower limit 0, upper limit pi. You have to integrate this. The problem is when you want to integrate it, it is one of those integrands for which there is no antiderivative available. You couldn't use the techniques you have like U substitution or trigonometric substitution. None of those will work. Therefore, you have to come up with another way. And you're thinking in the back of your head, it could be some form of a approximating integration technique or an approximation, and that is what you would have to do. When you're doing that approximation, arbitrarily come up with this n equals 4. The larger the number, the better, but you have to be practical. Therefore, n equals 4 is a good number. An interval, sample point, which will be midpoint, and f of xi, which will be your midpoint placed into your function, which is right here, sine of cosine x. When you're looking here at n equals 4, delta x, each interval is b minus a over n. You have pi over 4 is your delta x, the width of each interval, going from 0 but extending upwards by pi over 4. Then you have pi over 4 to pi over 2. Here you'll have pi over 2 to 3 pi over 4, and lastly 3 pi over 4 2 pi, and you've covered everything. 4 intervals, n is equal to 4. The middle of these will be represented by your midpoint right here. 0 and pi over 4, you know that'll be pi over 8. Pi over 4, pi over 2, add them up, divide them by 2, you should get 3 pi over 8, and then you're seeing a pattern. You're going by 2's in terms of these coefficients, so this must be 5 pi over 8, and this here must be 7 pi over 8. When you're putting everything here into your function, you know what you're doing. You're doing sine of cosine but pi over 8. But I'm not going to write all of that out. What we'll do is we'll put the values here into this function sine cosine x, where x is these values here. Keep your calculator here on the RAD mode. Again, our function here is sine, cosine, and you're putting your value, your midpoint value. I'll plug in the values. Keep your calculator here on the RAD mode. I'll put the values right over here, then at the end we'll determine our area below the curve from 0 to pi, which would be the end result of this definite integral. From here you're getting 0.7979. Here you're getting a 0.3734. You're putting these values here into this on the RAD mode. It's not hard. 5 times pi divided by 8, run that through. Here I'm getting a minus 0.3734, and here I'm getting a minus 0.7979. Now look, a very strange thing is happening. To determine the area, you're basically doing the sum of these f of xi's, and then you're multiplying them by delta x. All of these lengths, these are all lengths. Potential Riemann rectangles are coming into play. The lengths of the Riemann rectangles multiplied by the width once should give you your area. The only problem is when you add up all of these, the sum of these, you're getting a 0 times your delta x, which is pi over 4, and you're getting here 0. The end result of this definite integral ends up being 0, but it doesn't mean anything is wrong. What you have to do is, if you were to graph this out, sine of cosine x, you're looking at a graph which looks like this. It looks like this. Here's 0, here's pi. You're looking here at part which is above the curve and part which is below the curve. The only problem, this is positive a, minus a. They're equal in terms of numerical values, but they're opposite in terms of sign, and they cancel each other out, and hence you get this. It's a perfectly legitimate, correct answer. The main point or the theme of this video is there's some functions out there for which antiderivatives or the basic techniques do not work at all. You have to use approximating technique or approximation, and the end result here, 0, is perfectly right. And that's it for this particular video. Thank you for watching.